This topic on internal energy builds on the previous one about melting points and cooling curves, and is the bridge into the next two topics on specific heat capacity and latent heat. What you need to know about internal energy. Firstly, the internal energy is the total energy stored by the particles, be they atoms or molecules, in a system. The second thing is that internal energy is made up of the total kinetic energy and the total potential energy of all the particles that make up a system. You will find out what the kinetic energy is and what the potential energy of the particles are. And finally, you need to know that heating changes the energy stored in the system by increasing the energy of the particles. And the effect of that is it either raises the temperature of the system or produces a change of state. This is where we ended last lesson on change of state. We focused in that lesson on what happens. In this lesson, we're going to focus on why it happens. This diagram is very important, and you will need to print the Word version of this for later on. Potential energy is about the strength of the attractions or bonds between molecules. So, in pictures A and B, which has the greater potential energy and why? Kinetic energy is about the movement of the particles. In pictures C and D, which has the greater kinetic energy and why? Here we are going to talk about the kinetic energy of the particles. As you can see, this deals only with one state of matter, either a gas, a liquid or a solid. We don't have transitions. As you can see from the slope, the movement of the particles is changing. So as we go from a solid upwards, they vibrate more. In a liquid, they will move further apart. In a gas, they will move faster. Here we're going to look at the potential energy of the particles. This is associated with change of state. When solid particles melt and become liquid particles, energy is needed to overcome the forces of attraction between the particles. There is no rising temperature because the energy supplied is used to overcome these bonds. The same thing happens when we go from liquid to gas. When we do the reverse transition of gas to liquid, energy is released as bonds are formed, and so that the temperature stays constant. Similarly, when a liquid freezes, energy is released as bonds are formed. We are going to make a summary of what happens during this cooling curve. To do this, you will need to print out the Word file, and we will make labels on it. On the top half of the line, we will write in red the kinetic energy effects. Below the line of the graph, we will write in blue the potential energy effects. This will enable you to see exactly what is happening in a cooling curve in terms of kinetic energy and potential energy. This is a very important slide for you, and I want you to copy down the 3 bullet points. Kinetic energy is about the movement of the particles, and it is dealt with specific heat capacity. Potential energy is about the strength of the attractions or bonds between the particles, and this is dealt with under latent heat. Change of state is a physical change, so no new substance is formed as the particles are just rearranged, and the change is reversible, so there is no change in mass. This slide gives you 6 questions to test your understanding of internal energy. Do them in your book. When you have done them, use the next slide to green pen your answers. This slide and the next slide give you the answers to the 6 questions that you have attempted. Please green pen them and make any corrections. Be really careful about the language which is being used. Make sure you use the language which is given in the mark scheme. These are longer answer questions to gauge your understanding of the idea of internal energy. They are what we would normally call 4 or 6 mark answers. Be very careful with the language that you use. Be precise and accurate. These are the answers to the 2 previous questions. Green pen your answers, but be really clear about the use of language, in particular the use of kinetic and potential energies. Please make sure you do not get them confused. And thank you, and it's good night from me.